Next, we are having the types of a galvanic cell. The galvanic cell is the one where we learn that chemical energy is converted into electrical energy. The chemical energy is converted into electrical energy means there is a certain reaction takes place inside the cell, and due to that during that reaction, some heat energy is generated, which is converted into electrical energy. So the galvanic cell is the one where the spontaneous redox reaction occurs, and the result of due to which we get some electricity. That means the electricity is generated in the case of this galvanic cell, which is also known as a voltaic cell, and commercially it is known as batteries. So here I'm talking about the different types of battery. The battery which we are having, which are available in the market, we have the two different types of a battery which are available in the market. Means we had classified those batteries into two categories or the two types, depending on whether they are rechargeable or non-rechargeable. There are the certain batteries which are use and throw. Use and throw batteries, that is a non-rechargeable batteries, and there are the certain batteries which are rechargeable. We use it, the batteries are consumed, then again we use it. Like I can say the batteries which we uses in a torch, the battery which we use in a radio, or the battery which we use in a watch. These batteries are nothing but the use and throw batteries. That means these are non-rechargeable battery. Once they get discharged, they are thrown. But at the same time, the batteries which we use in mobile, the battery which we use in an inverter, the battery which we use in a camera, these are the batteries which are rechargeable batteries. Rechargeable batteries means we use it, the mobile consume all the battery becomes 0%, and again then we recharge it, again it is used. We recharge it, again it is used. So the primary batteries, commercially the batteries which are available, I can say the primary batteries are like some batteries are rechargeable while the some batteries are non-rechargeable. So whether the batteries are rechargeable or not, on the basis of that we had classified the batteries into two categories, that is a galvanic cell into two categories, I can say. Let's see these two types. The first one is called primary battery. And the second one which we have is called secondary battery. The primary batteries are those batteries which are non-rechargeable. Non-rechargeable means I can say they are use and throw batteries. What happens in case of in a battery? Then I can say that in a battery, suppose if there is a certain chemicals are kept, those chemicals are nothing but the reactant, I can say, and those chemicals undergoes a spontaneous reaction, means they get converted into a product by their own, and so that the chemical reaction is going on, that is a reactant is getting converted into product, and during that process some electricity is generated. So there is only one reaction is taking place, that is a reactant is getting converted into product. Now, if I'm talking about the secondary batteries, what happens in case of secondary batteries? Here also the same thing happened, but some additional, means in addition to this there is some more things are happening. These are considered rechargeable batteries. Means once they are consumed, then again we can recharge it, and after recharging again they are prepared or they are ready for the further uses. So what happens in case of secondary batteries? Suppose I have a reactant, that reactant forms, after the reaction we get converted into product. Suppose I'm I'm considering the batteries, the battery which we are using in a mobile. See, suppose in the beginning I have the 100%, the mobile battery is 100%. 100% means there is the reaction has not started, I can say, or I can say approximately all the reactants are present. Then from the 100%, that battery got reduced to 95, 96, 95, 94, 93, becomes 90, then 80, then 70. Suppose if the battery shows 70%. The 70% means that 70% battery is left. 70% battery is left, it means the 70% reactants are still there in a battery to react, or I can say the 30% reactant has been get converted into product. After some time, you will see that the battery shows 60% marks. Now the 60% means the 60%, there is a still 60% battery is left. 60% battery is left. That means the 60% reactants are still there to consume or to react. That means I can say 40% reactants are consumed. If I'm saying that 20% the battery shows 20% marks. That 20%, if the battery is at 20%, it means what, that only 20% reactant is left to react and the remaining 80% is consumed, and slowly it becomes 0%, 0%. As once it becomes 0%, that is a battery gets switched off. It means once it becomes 0%, that means all the reactant had got converted into product, so there will be no chemical reaction, so no electricity will be generated. Finally, we are talking about a galvanic cell which generate electricity. So all the reactant get converted into product, that is now there is a no reactant to react, that is to produce a electricity. So initially it acts as like this, reactant gives product. So this, now here the two reaction takes place in two directions. The first, during discharging, this reaction occurs. During a discharging, this reaction occurs. But once the battery becomes 0%, suppose here, then what is our next step? We directly take the mobile and we connect it to the external energy circuit, external energy source, that is some electrical socket we connected. Now, when we connect it to the external energy source, we all know that external energy source is having more potential compared to the potential which is produced by the battery, that is a galvanic cell which is present inside the mobile. So here, once we connect the battery or the mobile to the external energy source, and since the external energy source potential is more than the potential of a battery, that's why the reverse reaction takes place. As we had learned in the Daniel cell, that when the external energy source is greater than 1.1 volt, that is the voltage of or potential of the Daniel cell, then reaction get reversed. So when it is connected, when the mobile is connected to the external energy source, the reaction get reversed. Reaction get reversed means whatever the product we have, now they start getting converted into reactant. So reactant is getting converted into product. This happens when discharging takes place. That means this happens during discharging. The battery is getting discharged. Then this is spontaneous reaction. When this reaction is taking place, simply I will say the battery is acting as a galvanic cell. Now let's talk about the reverse process. Product is getting converted into reactant. This happens when we are recharging it. And we are reversing the reaction, but this reaction will not reverse by it is not getting reversed by its own. We are reversing it by using electricity. And since we are using it by electricity, that means the process is non-spontaneous. And when a reaction is carried out by using electricity, the reaction is called, then that cell is called as electrolytic cell. So during a discharging, I can say the battery is acting as a galvanic cell, while during a recharging, it is acting as a electrolytic cell. So a secondary battery is a one which at a time act as a galvanic, as well as the next time it act as a electrolytic cell, means when you recharge it. So this is about the batteries, that is a primary battery. In case of primary battery, only a single reaction takes place. That means only the reactant is getting converted into a product. Here this reverse reaction doesn't occurs. Now it's but for the secondary battery, I can say that there is a certain numbers which can means this can be recharged for a certain numbers. Primary batteries which are non-rechargeable and use and throw, they are generally, I can say that, cheaper compared to the secondary battery which are rechargeable. So here the primary battery in a syllabus, we have the two primary batteries about which we are going to learn. The first one which we have is dry cell, and the second one in a short we have mercury cell. The dry cell, I can say the cell which we use in a torches, that pencil cell I can say, or that another cell which we are using in a torch like everyday and etc. That everyday and Nippo cells and all. Mercury cells are nothing but those cells which we use in a watch, or I can say which we use in an earphone. Then next here the secondary battery which we are going to learn is lead storage battery, which we use generally in inverter, and nickel cadmium battery. So we are going to learn about these two types, the two example for this and the two example for the secondary battery. So let's start with the first type of the cells, that is the primary cells or the primary batteries. And as I said, the primary batteries are those batteries which are non-rechargeable batteries. Means once the reactant get converted into product, then the reaction cannot be reversed. That means the recharging is not possible. Here we have two examples for the primary batteries, out of which the first one is a dry cell, which is also known as a Leclanc cell, which is because it is given by the Leclanc, that's why it is also known as a Leclanc cell. So the dry cell, which are non-rechargeable batteries, which is considered non-rechargeable battery. Now let's see dry cell about it. Okay, so we have this at the center, that is a graphite rod. This graphite rod is nothing but it is acting as a cathode. So it is a black color graphite rod which is acting as a cathode here. The whole dry cell is made up of zinc container, which is acting as a anode in this case. So it is made up of zinc container. Then I can say that there is a mixture that is around the graphite rod. There is a mixture or the paste of, I can say, manganese dioxide and carbon, where the manganese dioxide is act as a used to prevent the polarization created by the or produced by the hydrogen gas. We will see what is polarization, that method that is. And then the whole container, that is except this, the whole dry cell is filled with some electrolyte, and that electrolyte is nothing but it is a mixture of zinc chloride and ammonium chloride. That is, again I will use a word paste of zinc chloride and ammonium chloride. So graphite rod is acting as a cathode and this container is acting as an anode here, I can say. You might have seen this this is a dry cell, is nothing but I can say that cell which we use in torches. And if you had any time if you had broken that cell, then you might have observed that is at a center there is a black color rod, and that black color rod is nothing but the graphite rod which is acting as a cathode. And then there is a container, that is a container is zinc container which is acting as an anode here. And internally this container is, I can say that there is a internally it is lined with the some paper, porous paper, which prevent or which prevent the mixing of, or which separate this ammonium paste of ammonium chloride and the zinc container, because ammonium chloride being acidic in nature, it produces a corrosive effect on the zinc container, due to which the zinc container undergoes oxidation and we lose some zinc because of this oxidation, that is because of that rusting, I can say. So the rusting, the dry cell. The dry cell, the name is given the dry cell because here the ammonium chloride, that is electrolyte. Generally, electrolytes which we use in any galvanic cell or in electrolytic cell is generally in a liquid state. But here the electrolytic cell, here the electrolyte, that is a ammonium chloride and a zinc chloride. It is not purely in a liquid state, but it is in a paste form. So now let's see how it works. So here, as I said, the anode. What is anode? So here I can say that anode is a zinc container. That full container is acting as anode. The cathode is graphite rod. And then third, that is the electrolyte which we are using here. Electrolyte is nothing but the paste of ammonium chloride and zinc chloride, where the ammonium chloride is in the form of ammonium ions, I can say, and chlorine ions. That means it is in a dissociated form, right? So now let's see what reaction is taking place in this case. So the reaction taking place on anode and cathode. So first, the reaction taking place on anode. Here the anode is a zinc container, and being an anode always undergoes oxidation. So the zinc container which we are having here undergoes oxidation and produces zinc ion plus 2 electron. That is, the oxidation is taking place. Now the cathode. The electron which is produced on the anode through the external circuit, it reaches to a cathode, that is a graphite rod, and when it reaches to a graphite rod, then ammonium ion which is present in an electrolyte, that ammonium ions get attracted toward the graphite rod, that is toward the cathode, because of this electron which is getting moving to this cathode. So ammonium ions gains electron from this and get converted into NH3 and produces hydrogen. But as we know that hydrogen never exists in the monoatomic form, so H2 it should be. So to get H2, and it takes 2 electron. So on a cathode, this reaction is taking place. That is, ammonium ions get attracted on a cathode, it gains electron and produces ammonia gas and hydrogen gas. Now here the production of that hydrogen gas creates a problem to us. What happens? The whole reaction is taking place on the surface of a cathode. So the hydrogen gas which is produced on the surface of a cathode, that hydrogen gas suppose if it is a graphite rod, that is a cathode, then hydrogen gas which is produced, it gets sticking on the surface of the cathode. And when hydrogen gas starts sticking on the surface of the cathode, then ultimately I will say that cathode surface area decreases, and since the cathode surface area decreases, therefore the rate of reaction goes on decreasing, and so that the electrode potential will go, or the cell potential will decrease, that is the life of battery will also decrease. So to avoid that deposition of hydrogen gas, here we had surrounded that graphite electrode by the manganese dioxide. Now what MnO2 do? This sticking of hydrogen gas on the surface of a cathode is called as a polarization. So MnO2, what happened? MnO2 is act as a polarizing agent. What it do? It oxidize the H2 to H2O. So H2 which is produced here, that combines with manganese dioxide, or I can say manganese dioxide oxidize it, and so that we get H2O and plus we get Mn2O3. So overall I can say that on cathode the two reactions are taking place, that is, one is a reduction and the second is a polarization part. So let us add both the reactions, that is a reaction which is taking place on cathode overall. So H2 will get cancelled. What is left? 2 moles of ammonium ion plus 2 moles of MnO2, which plus 2 electrons, which gives 2 moles of ammonia plus Mn2O3 plus H2O. So this is the overall, this is the reaction which is taking place on cathode. So overall cell reaction I want now. So for the cell reaction, for getting a cell reaction, we add anode and the reaction taking place on anode and cathode. So let us add reaction taking place on anode and cathode. On anode, this reaction is taking place, that is oxidation, and on cathode, this whole reaction is taking place. So while addition, I can say that the electrons will get cancelled. We have to add this one and this reaction. Okay, so let us add. On the left hand side, we will have zinc plus 2 ammonium ions plus 2 moles of MnO2, which gives zinc 2 plus ion plus 2 ammonia molecules plus Mn2O3 plus H2O. So this is the overall reaction which is taking place in the case of this dry cell, that is a Leclanche cell. But in the case of dry cell, what happened, there is a one problem that while using ammonium chloride, I can say that it is made up of ammonium hydroxide and HCl, and since it is made up of ammonium hydroxide and HCl, therefore I can say that ammonium chloride, that is a salt of a weak base and a strong acid, and that's why the ammonium chloride is an acidic in nature. And being acidic in nature, what it do, it oxidizes the zinc ion. Here we also want that the zinc atom should undergo oxidation, but that time when the zinc is undergoing oxidation, that electron get transferred to the cathode. But due to that acidic nature, what happens, the zinc undergoes oxidation, and that electron, instead of reaching to a cathode, it is gained by the hydrogen ion. So what happens, due to that ammonium chloride, that extra zinc which is undergoing oxidation, due to which I can say that our reactant goes on decreasing, and our reactant goes on decreasing, that means I can say the life of a battery get reduced, right? So just to avoid that reduction in the life of a zinc, now we are using an alkaline dry cell. In alkaline dry cell, what we do, we just replace the ammonium chloride, that is by this electrolyte, by some basic substances like a potassium hydroxide. So now nowadays we are using, instead of pure, that is actual dry cell, we are using now the alkaline dry cell, whose life is little bit more than this normal dry cell. The dry cell potential is 1.2 to 1.45 volt. So it's a cell potential. Cell potential means I can say E naught cell value, it is 1.2 volts. Now let's after the dry cell, now let's talk about the another example of the primary battery, that is mercury cell. The mercury cells are those cells which are generally which we use in means they are the small size cells which are used in watches, which are used in hearing aids, right? We use it in a camera, that small batteries which we are using. Again, they are also non-rechargeable, use and throw battery. Once they get over, we just throw it. Now in the case of this mercury cell, now let's see what is anode and cathode in this case. Here in this case, the anode is a zinc. The cathode is mercury oxide, that is mercury 2 oxide, where the mercury oxidation state is 2, so HgO. The electrolyte which we have here, the electrolyte is the paste of zinc oxide and KOH. So this is the electrolyte which we have. Now let's see what reaction takes place in the case of mercury cell. So the reaction taking place on anode and cathode. So first one, the reaction on anode. Anode, which is made up of zinc, contains a little bit amount of mercury, that is zinc amalgam, I can say. That zinc amalgam undergoes oxidation in the presence of OH minus ion. OH minus ion we are getting from the electrolyte, that is KOH. It loses electron, that is undergoes oxidation, and get converted into zinc 2 plus ion, plus we get, this undergoes oxidation, zinc 2 plus ion, but forms zinc 2 plus ion, combines with O and produces zinc oxide, plus we get H2O, and plus 2 electron is released. So here the oxidation is taking place, I can say, the loss of electron. or the zinc has oxidized, 0 oxidation number, and now it has become +2. Then reaction taking place on cathode. So what is that? What reaction is taking place on cathode? So I can say on the cathode the electrode is mercury oxide, HgO. So that HgO gains electron in the presence of water and produces Hg, and that oxygen is gained by the H2 and get 2OH minus ion. So this is reduction reaction. So this is the reaction taking place on anode, this is the reaction taking place on cathode. So let us add both the reactions so that we will get a cell reaction here. So cell reaction, here the electrons will get cancelled, equal number of electrons. So we will have zinc amalgam, or I can just write zinc plus HgO plus 2OH minus plus H2O, which produces zinc oxide plus H2O. Here I can say that OH minus ion also get cancelled. So OH minus ions will not be there. Zinc oxide, at the same time H2O is also getting cancelled. So here I'm writing it again. The zinc plus HgO, which gives zinc oxide plus Hg. So finally this is the reaction which we are getting in a mercury cell. So in a mercury cell I can say that there is a no ion is forming. In an overall cell reaction there is a no ions, and since there is a no ion, so the potential of the cell, like in case of this, the potential of the cell does not vary but it remains constant, and it have a better life compared to the normal dry cells. Its the potential is, that is E0 cell value for this mercury cell is 1.35 volt. So these are the types of the primary batteries, I can say, the dry cell and mercury cell, which are non-rechargeable battery. That means they are use and throw battery. Once they get discharged, they cannot be recharged again.